This catalog documents every German jet and rocket aircraft prototype that flew during World War II. Experimental platforms, combat precursors, and revolutionary designs that reshaped aviation forever. Germany's jet story began before the war. Engines came first, airframes followed. Heinkel 176, rocket-powered experimental aircraft flown in 1939, proved liquid-fueled rocket propulsion in piloted flight. The aircraft tested extreme acceleration and climb. It established Germany's early rocket research foundation. Heinkel He 178, the world's first turbojet-powered aircraft, flew in August 1939, powered by a single Heinkel He S3 engine, demonstrated sustained, controlled jet flight. The design was simple and purely experimental. Its impact was historic, not military. Early success did not trigger immediate production. Attention shifted toward practical fighters. Heinkel He 280 V1, first jet fighter prototype to fly. Twin engines mounted beneath straight wings. Introduced tricycle landing gear and ejection seat, features decades ahead of their time. Heinkel He 280 V2 through V8. Multiple flying prototypes tested engines and armament layouts. All demonstrated superior speed to piston fighters. Engine unreliability doomed the program. The fighter never reached service. Messerschmitt entered jet development later, but with greater industrial support. Messerschmitt Me 262 V1. Initial prototype flew with a piston engine in the nose, jet engines unavailable at the time. This configuration tested aerodynamics and handling. It kept the program alive. Messerschmitt Me 262 V2, first pure jet-powered Me 262 prototype, flew with Junkers Jumo 004 engines, revealed unprecedented speed and climb, exposed engine fragility issues. Messerschmitt Me 262 V3, refined engine nacelles and air intakes, improved stability at high speed. These changes shaped the production design. Prototype flying continued relentlessly. Messerschmitt Me 262 V4, tested armament installation and center of gravity, confirmed feasibility of heavy nose-mounted cannons. Firepower exceeded any Allied fighter. The jet interceptor role was validated. Messerschmitt Me 262 V5, explored landing gear and takeoff behavior. Early tailwheel configuration proved dangerous. Jet exhaust overheated runways during takeoff. Tricycle gear became mandatory. Messerschmitt Me 262 V6 and V7, refined control surfaces and cooling systems, addressed early vibration problems. Each flight solved critical design flaws. Production grew closer. Messerschmitt Me 262 V8 and V9, finalized operational configuration. Confirmed reliability improvements. Over 20 prototypes flew in total. The world's first operational jet fighter emerged. Parallel bomber development followed speed advantages. Defense through velocity replaced armor. Arado Ar 234 V1, first jet bomber prototype to fly. Initially used a takeoff trolley and landing skid. The narrow fuselage forced radical solutions. Operational practicality was limited. Arado Ar 234 V2, refined engine installation and fuel systems. Confirmed high-altitude performance. Speed exceeded most Allied fighters. Survivability relied on velocity alone. Arado Ar 234 V3, tested camera installations for reconnaissance. Defined the aircraft's primary operational role. Jet reconnaissance became viable. Interception was nearly impossible. Arado Ar 234 V4, introduced retractable tricycle landing gear, solved operational limitations. This change enabled repeated sorties. Production variants followed. Arado Ar 234 V series continued. Over 20 prototypes explored engines and bomb loads. All contributed to the final design. The Ar 234 became operational, too late to affect the war. Rocket propulsion returned for interception. Extreme climb was prioritized. Messerschmitt Me 163A V series, rocket-powered interceptor prototypes, designed for point defense, powered by volatile chemical fuels, provided incredible acceleration. The aircraft reached unprecedented speeds. Powered flight lasted only minutes. Me 163 prototypes tested handling and glide recovery. Landing skids replaced conventional gear. Explosions were frequent. Pilots faced extreme danger. Despite flaws, prototypes flew successfully, the fastest aircraft of the war. Germany sought simpler jets for mass production. Desperation shaped design. Heinkel He 162 V2, emergency jet fighter prototype. Constructed largely of wood, the engine mounted atop the fuselage. Simplified production but altered handling. Heinkel He 162 V2, structural failure during demonstration flight, exposed rushed design flaws. Subsequent prototypes reinforced wings. Flight testing resumed. Heinkel He 162 V3 through V10 explored control systems and stability, improved safety and performance. Over 50 prototypes and pre-production aircraft flew. The Volksjäger concept matured. Operational deployment began in 1945. Numbers remained limited. Radical aerodynamics pushed boundaries further. The flying wing emerged. Horten Ho IX V2, unpowered glider prototype, validated flying wing stability. The design minimized drag dramatically. No fuselage or tail surfaces. Horten Ho IX V2, jet-powered flying wing prototype. Twin engines embedded in the wing. Achieved remarkable speed and efficiency. Handling proved manageable. An engine failure caused a fatal crash. The program ended abruptly. The design influenced post-war stealth concepts. Its legacy endured. Bomber innovation continued under pressure. Wing geometry experimentation followed. Junkers Ju-287 V2, forward-swept wing jet bomber prototype. Flew in 1944. The configuration improved low-speed handling. Structural stress remained a challenge. Junkers Ju-287 V2, refined engine layout and systems, expanded test envelope. Hybrid engine configurations provided thrust. Operational potential was evident. The war ended before refinement. The concept moved east after capture. Variable geometry entered experimentation. Adaptability became a goal. Messerschmitt P.1101, variable sweep-wing fighter prototype, completed but not flown. Ground-adjustable wing angles were tested. Aerodynamic data was gathered. Captured by American forces. Influenced later variable sweep designs. Pure research aircraft supported combat programs, often overlooked. DFS-194, rocket-powered swept-wing research aircraft, flew before the Me-163, tested transonic behavior and stability, provided critical data. The aircraft validated swept-wing rocket flight. Its contribution was foundational. Vertical launch concepts appeared late. Defense became desperate. Bachem Ba 349 Natter M23, vertical takeoff rocket interceptor prototype, designed for point defense. Unpowered glide tests were conducted. Powered flight followed. One manned launch ended in disaster. The program was terminated. Despite failure, the concept proved vertical launch feasibility. Missile-age ideas emerged. Other minor jet prototypes flew briefly. Many remain obscure. Heinkel P.1101 test articles. Experimental jet fighter concepts. Limited flight activity recorded. These explored compact interceptor layouts. None reached maturity. Captured German aircraft reshaped Allied aviation. Knowledge transfer accelerated progress. British, American, and Soviet engineers studied every prototype. Jet age advancement followed. None of these aircraft altered Germany's fate. All altered aviation history. They arrived too late. They flew too few. Yet every flight proved jet propulsion was inevitable. The future had already taken off. From crude test beds to revolutionary fighters, from rockets to flying wings, every German jet prototype that flew, a legacy written in speed and flame.